I will do my best to do that as well. All righty, so welcome to our class. Let's go ahead and have a look at all the things that we're going to do in our class, and then we'll eventually get to the math. So one of the things you were supposed to do before class started was get a set of class participation cards together. Because during the class, right, again, like I said, we're going to try and be as interactive as possible. So there will be questions, right, things for you to practice with, just for me to get a real quick feel for how the class is going. So that gives me feedback to know, like, oh gosh, we're all getting this and we should probably move ahead. Or, ooh, there's a topic that we need to do a little bit more work on. So here's your very first question. All right. Now, the beautiful thing is that if you didn't make your cards already, that's fine because we have to use the chat box anyways. So in the chat box, you could just enter the letter that corresponds to which of these beginning tasks in the box have you already accomplished? Well, see, I told you our class was on top of things. All right, as suspected, we have lots of A's and B's, but again, if you're not an A or B, right, that's okay, right? Because now you've got that information. You can check onto Blackboard. You can look back at all the old announcements, make sure you're not missing anything. But I haven't yet looked at your start of semester assignment. That one will sort of give me a sense of where we all are and sort of what our backgrounds are. That'll help me tailor responses to you. A lot of you have already been on Blackboard and looked at our two giant courses that we have there. There's a lot going on there. We have one Blackboard site just for our Chem 031 course, sort of assignments and topics there. That will be there for you to focus just on those things that go into the grade for the 031. That'll help you to really monitor your progress there. And then the bigger site, which is the one where all the announcements will be in our Chem 131 site. And that's going to contain absolutely everything else. That's going to contain the lab, the discussion, and then our regular coursework and all the support resources we have for that. So obtaining a textbook, I think, was a lot easier this time because it kind of happened automatically for a lot of you, unless you opted out of the slingshot. Do we all have our calculators with us? Right, so a little thumbs up would be great if you've got your calculator. Perfect, right? Once we get through this introductory stuff, we are going to be looking at how to use our calculators, making sure that we're familiar with that and right and kind of have that down. So we'll need that. On Thursday, we will need our goggles, our safety goggles. We'll actually be looking at some things in our lab in addition to doing our orientation. So goggles will be a thing to have. Their class participation cards we've talked about. I've already given you feedback for those who have turned in their weekly preparation guides. Again, fantastic jobs. And watching the significant figures videos, I'm thinking that's a topic we're not going to get to till Wednesday. So you have another day or two to check those out, either before or right after class would be ideal, or both, actually, is probably more ideal. All right. Any questions on these assignments or tasks to complete here to get us off to a good start? Yes, if you've still got one of those, I'll say fancier calculators left over from high school or some other math class, like a TI 83 or 84, you can absolutely use it. What you want to do though is get sort of a less expensive one if you can, or check one out from the math help centers. That way you can start practicing on the calculator that you're going to be using on exams, right? So as long as it's not a graphing or programmable, or not, excuse me, not graphing, as long as it's not a programmable calculator, it should be fine even for the whole semester. Okay. Other questions? All right. Yes. I am okay with you using a TI 84 as long as, like I said, I don't think it has any programmable features. So TI 84 definitely is a scientific calculator. So yeah, but the ones that are advertised as scientific, though that's kind of all they do. They don't have that extra graphing ability to them that your TI 83s, 84s will have. Um, the reason for having a less expensive one is because we're going to take it into lab. So we don't want anything unfortunate to happen to our wildly expensive TI 84 calculator that we might need later on in our math classes. So kind of just be kind of cautious there. We definitely don't want to be using our cell phones as a calculator though, because we're not going to be bringing those into lab. Um, they don't do all the things we want it to do. Right. Okay, perfect. Questions? All right. Again, as you think of questions, feel free to raise your hand, put it in the chat box. Um, if for some reason it's not catching my eye as a raised hand or in the chat box, feel free to just jump right in. That is okay as well. That is one of the challenges of being in this virtual sort of setting is I can't see your faces, so I can't see when you've got those questions over your head. Kind of encourage them out of you. All right, other questions, anything? All right. Okay. All right, so let's take a look at our two sort of separate classes here, right? So again, those of you who have looked at our syllabus, which is I think most of you, you know that we have two separate courses here. They're going to work together. And in fact, you're not going to be able to tell where one ends and the other one stops, right? So the Chem 031 is that support course. That is the part that's extra, that is different from a regular first semester general chemistry course. I mean, yes, I am sharing my screen. We are currently looking at our class slides for 0. Right. Right. So feel free to go out and back in. Sometimes that helps when we're sharing a screen there to see if that helps clear that up for you. Or you can follow along. So we're on the slide that looks like Chem 031 and Chem 131. All right. Anybody else having problems seeing the screen, seeing the shared slides? All righty. Okay, so if you are having a challenge, try hopping out and back in. All right, so we've got a couple of friends who can't see. Okay. All right, so let me do that. Let me turn off my sharing and then go back to sharing. All right, did that improve things for anybody out there? All right, perfect. Okay, so let's carry on and take a look at our two components, right? Because we have tons of assignments in your calendar, right? They are color coded. That is one of my favorite things to do. So everything that counts for your Chem 131 grade is going to be in blue. Everything that's in your Chem 031 grade is going to be in orange on our calendar. And they're going to be held in those two separate Blackboard sites. So anything that counts for our Chem 131 grade is going to show up. If you're looking for something that's part of your Chem 131 grade, it's going to be in that Blackboard site. If you're looking for an assignment or a resource that supports something that's going to be part of your Chem 031 grade, it'll be in that site. All righty. Okay, so here's what we've got going on. So in Chem 031, for starters, the bulk of those points, there's 500 points available altogether. Your job is to get to 350 points. That is what's considered passing, 70%. in Chem 031. And those are our only choices for grading in Chem 031. You're either going to be graded satisfactory or unsatisfactory. So these are all the assignments and things that are not a part of Chem 131. And those are the bulk, again, of those are our developmental practices. These are what our former students say are the most helpful things for them. So there are a total of 29 of these assignments scattered over the semester, right? So do the math, that's 2 or 3 a week. And they're designed to get you a little more practice at that super introductory level to some of our topics. And they're chosen to be the ones that are the most challenging. I will tell you that our first few are the most they're not the most difficult. They're the longest ones. They're the longest ones, and you're going to find there's probably a few more at the beginning of the semester than towards the end, right? So they're going to tend to kind of bunch up in some weeks. So look ahead. That's part of what the planning is on the preparation guides for each week, is to think about what to do and when it's due. But they're 10 points each, so we're going to keep your best 25 out of 29, right? So again, missing any one or not doing well on one, not a big deal. And these are the ones that are graded special, right? These are the ones that are graded. You get half the points just for doing it, just for making an attempt. And then the other half of the points are for correctness. Okay. So that's the bulk of what's going on in Chem 031. The remainder of those points to get you to 350 points out of 500. Oops, I am going backwards. Are what I like to call the good habits points. So that's another big chunk there. That's part of that developmental or that support is encouraging those good habits that are going to serve you well, not just in this class, but hopefully in all your classes. So those are things like your start of semester assignment that many of you have already done, right? Reading the syllabus, doing all that ahead of time, right? Sort of all that kind of thing. Going to the Science Learning Center, right? So there's going to be points for that. You get 1 point per visit for up to 30 for visiting the Science Learning Center. So that's twice a week, which you might want to visit more than that, but right, we try and encourage that. Those are where our attendance points are, sort of doing extra things outside of class, like going to different seminars or professional events. Those are all part of those things that are good habits for you. What else is in there? And the good habits reflection. So at the end of every week, there's a short little opportunity for you to kind of summarize the week, right? With some guidance, right? Kind of helping you sort of just sort through that, right? And make sure that you've kind of have that preparation at the beginning of the week and that summarizing at the end of the week. That's a good time frame for us. Our class is very, again, very structured, pretty much on a weekly basis. So you're going to be able to expect the same things every week. So being able to prepare for the start of your week and then summarize at the end of your week, that's just kind of keeping you consistent and constant and helping you to develop that sort of discipline or that habit of this is what I do on these days of the week to stay ahead or on top of things in this class. And of course stuff comes up, but that's again sort of there as sort of guidelines or guardrails to kind of help us keep track of all the things that are going on in our class. So those are again full points just for completing them, right? They're about you and your reflections, so it's kind of hard to get those wrong. They can really only be incomplete. Righty, perfect. All right. There's also, to get the remaining 100 points, a Chem 031 final exam, which is 100 points. That'll happen during finals week. Again, if you accumulate enough points during the semester, you may not need to take that final. Most of my students have taken it anyways, just as kind of a little warm up for the Chem 131 final. So it's a nice little sort of test or diagnosis of what's going well in chemistry, sort of in those fundamental things. So the 031 final is optional in the sense of if you already have 350 points in Chem 031, whether you have 350 points or 450 points, it's all the same grade. So at that point, you can choose not to take it. But if you only have 270 points, then you do need to take that Chem 031 final to earn enough points to get to your magic 350 points. Okay. Alrighty. Okay. And we'll, of course, we'll talk more about that as we get kind of closer to the end there. We'll be monitoring, right? You can monitor your progress all along, and you can always check with me if something seems out of line or you're concerned about how a class is going. But that's again kind of all of those activities that we've talked about over there. Those are all things that are not typically part of a Chem 131 class. Those are all sort of points that are for all of those support activities, all of those sort of I guess you could call them soft skills, those good habits that we're developing in those extra practice as kind of that filling in any gaps that you might have in your background. All right, so that's the support part. That part is graded as a satisfactory or unsatisfactory. Chem 131, this is our, right? We're going to meet all the same requirements in Chem 131 than a regular standalone first semester general chemistry class. So everything that we're going to see on the other side of our screen there, those are all things that would normally be a part of a regular class. We're just doing it while doing all these other support things and this extra time that we're going to have. We're going to have an extra 2 hours a week to be together to do all those extra practices, to give you more time to sort of get ourselves caught up and moving forward. All right, so let's see what's going on in this part of our class. Here we are going to have, hello. All right, well, we don't like to talk about this on our first day, but yeah, there'll be exams. There'll be exams. We're going to have 5 exams. We're going to keep your best 4, right? So this class is very forgiving in the sense that there's a lot of best out of so many's in it. So if you have a bad day, right, or a bad week, right, or things just aren't kind of clicking for something, that's not the end of the world, right? We can right have another chance to go back and correct what those challenges or deficiencies were. So that's why I like this class. That's why we have 5 exams instead of 4, right? So if you have friends in other chemistry classes, they may only have 4 exams. We're going to have 5 so that we get to drop the one that we had the most challenging with. Okay. We've got the preparation guides, which is what you've already seen, right? So again, those are 3 points each. We're going to keep your best 12 out of 14. There's 14 weeks in our semester. So again, if you forgot to do one or don't get a chance to, again, not the end of the world. I would encourage you to do all of them. The students that typically do the preparation guides regularly, right? They're able to get more out of each class, which makes them sort of start their practice time a little bit ahead, right? Because their brains already thought about, well, what are we going to be doing in that class? And so they're more ready for whatever we do in that class to sort of just get everything out of it that they can. So I do encourage you to do all of those, even though we drop 2. It's to your advantage to do all of those. They're just there to kind of help guide your reading. We're going to have weekly quizzes at the end of every week. They're going to be on Blackboard. Again, they're only 2 points each. We're going to drop your lowest 2. So again, very sort of a very forgiving thing. So if you have a bad week or just aren't quite ready for the quiz or forget to do it, again, we're very, this course is very forgiving in that sense. The topic of that weekly quiz is going to be whatever we did during that week. You'll find though that a lot of what we do builds on what came before. So you may see some things from previous times, but that won't be the focus of the quiz. Right. And I think they're just like 10 minutes long. So they're very short and very quick. All right. We will be doing discussion groups. So that's groups of, let's say 4 or 5 when we get back together again to solve a small set of problems. Those will take place on Fridays typically. You'll turn in 1 paper for the whole group. And then, like I said, it'll be on those topics from that week. So it's a chance for you to, again, use your words and talk with each other about some problem solving strategies for that. And for those, again, we're going to keep your best 12 out of 14. So again, very forgiving. All right. The practice portfolios, that's probably the thing that's the most different. So let's spend a little bit of time on that. The practice portfolios will happen every week. We're going to keep your best 12 out of 14. They are basically all of your practice for the week. So this is, you can see from the number of points, this is sort of our big assignment for the week. So this is the one not to wait until the last minute to start on. These are problems that are from our textbook or a few other extra sources for some of our beginning topics. And in these portfolios, your job is to basically solve all those problems, show all your work, so not just write the answers, because the answers are already given to you. You already have the answers to all the problems in the portfolio, right? So the answer is not the point of the portfolio. The process is, and being able to show and document your problem solving strategies. So these problems are listed on the preparation guide. They're listed on Blackboard in for each portfolio section when you look at that assignment. Also in your purple folder, when we get together, I'm going to have a printout of all of those assignments for the whole semester, just so you have them all in one place. But you should definitely start those as soon as possible. Especially the first one or two. Those ones are going to take a little bit longer because they just have more in them, because we are doing more things the first week than in any of our other weeks. So your job is to, again, show all your work, right? So you're going to be writing these out. We're not going to be typing these. That's tragic for chemistry, right? To be able to show all of our superscripts and our subscripts and our powers of 10 and trying to show math when you're typing is chaos. So these will be all written out in your hand. Excuse me, and then turned in by the end of the week. So you'll do those problems, you'll check your answers because, like I said, you have all the answers there. And then you'll come back and revise them. Cami, you have a question?
Hi. Yeah, I was gonna ask, so you said that we have to type it um on a document. Can we, like, I have an iPad, so I'm able to write it down by hand. Is that
Mhm.
okay too, or do
That is
I have
okay
to
too.
type
Yeah.
it?
Hmm.
Okay.
Yeah. So by handwriting, it literally just means in your handwriting. It doesn't mean you have to do it pen on paper, although that works. But a stylus on iPad also works, right? As long as, like I said, we're not trying to type math equations. That's going to get craziness. And when we get to formulas and structures, it's going to become next to impossible. So yeah, so start as soon as possible. And for those of you who are not believers, who like, I type everything, I will tell you a story. I had these two lovely ladies who just love to type everything. And they were struggling and struggling with one of our week one topics. And I said, please, ladies, will you please try writing it out by hand? And they did. They actually finally did it, and sure enough, their understanding improved. They came back and said, "Oh my gosh, I understand what I'm doing now that I'm writing it." Lots of studies have shown that writing is better than typing. And it doesn't matter whether the writing is, again, pencil on paper or stylus on iPad, that is activating a different part of your brain and actually helping the learning process more. Um, my students from previous semesters who have, uh, they refer to themselves as victims of the practice portfolios, but I'll say participants in practice portfolios, found that by the time they finished doing that practice portfolio, they were really ready for an exam, right? So by doing all of that work, which seems like a lot at the beginning, you'll find that you probably need to do less when it's time to study. You're not doing all that cramming towards the end, because what you would do to get ready for the exam is do a lot of practice problems. And the portfolios are effectively sort of forcing you, or I'll say encouraging you to do exactly what you need to be successful, which is to practice as many problems as possible. right? So your job will be to do those problems, show all your work, all the steps, all written out, and then check your work, right? Because it doesn't do you any good to solve those problems if you haven't checked to see, well, gosh, did I do them right? And then revise your work, right? Depending on what the error was, right? Did you have a conversion factor wrong? Did you not know what the definition was? Did you enter it in your calculator wrong? Did you do it to the wrong number of significant figures, right? And then correct your problems. And if you can't correct your problems, then you write a little question to me. And when you turn it in, I will answer all those questions. Um, so again, when we get our little purple folder, I'll point out to you the grading rubric for that. It's online. It's on Blackboard as well, so you can see it. But 3 of the points are just for turning it all in on time. 3 of the points are for having it organized. 3 of the points are for checking all your work and making those corrections, and 3 of the 12 points every week. I'm going to grade some random problems, right? Doesn't make sense. I can't grade all of them for everybody. So I'll pick some random problems to actually grade for correctness. But again, remember, you have the answers to all these questions already. So probably should be able to figure them out. So start them early enough in the week that you can get help if you need it from the Science Learning Center, from me, from your study group. Um, Definitely do not start these like late on a Friday. That's probably not a good plan. Starting them at 9 o'clock on Saturday when they're due by midnight, also not a good plan. So these assignments, by the way, the portfolio ones are the only ones that you can keep turning them in late and keep adding to. So if you say didn't get all the problems done, turn in what you have, and then you can always add to it, right? So there are points for turning it in completely, but not quite on time. So again, you'll have up to 2 weeks to get sort of your final portfolio in. But I will grade them all along as soon as I can to give you that feedback as soon as possible, so that if you want to add to it or make any changes, you can do that. Right. And that's kind of unusual. That's probably a different way of doing problems than you've done in past classes. Right? But again, we're all about the process. Right? Right? It's not about getting the right answer all the time, although that's great. But we're again working on developing that process. All right. Do we have questions on that one? That particular assignment. That's a challenging one. Right. Lab is 20% of our course, right? So it's going to have pre-labs, right? It's going to be every week, a pre-lab, a lab quiz every week, except for this first week. We don't have one this week. A lab report, worth some variable amounts of things. And then there'll be a lab exam down in week 12. And we'll talk more about that as we get closer to it. But I will tell you right now, the best thing you can do to be ready for that lab exam is to prepare and be alert and attentive during lab. There's really no substitute for that. And hang on to your lab reports, right? So after you get them back, make sure you can find them when it's time for our lab exam. Right. So hopefully that'll be a fun time in our lab. And then we have final exam. We take a national exam, the American Chemical Society's national exam. And it'll be worth a little more than, well, not quite 1.5 of our regular exams. So it's a good amount, but not an overwhelming amount. And that will cover everything for the whole semester. And that'll happen, for us, it'll happen Wednesday, finals week. All right. So it's all out there. And that totals up to be 1,000 points. So that makes it a nice round number. All right. So the question in the chat box, do we get any great certificates for passing this national exam? And the answer is unfortunately no. They give out certificates, the American Chemical Society, when you graduate with their certification in a 4-year program. I don't think they have any certificates just for the national exam. But it's definitely a point of pride. And that's, again, when you're transferring, if you're transferring to a 4-year place after this, or applying to a professional program, right? That's something you can always add that, yeah, we took this national exam, right? So it wasn't just my college instructor didn't just write a nice exam for us. All right, Haley, go ahead.
I was just curious, so what is the reason for doing this like state exam versus, a curated exam that you guys like as the chemistry department would like curate?
Mhm. So yeah, so it is because it's a national exam, it is it's one way of demonstrating that our chemistry program is on par with anything else that's out there. Yeah, so our students do as well or better than the national average on that. So again, it's almost like a point of pride for
Right.
us.
Okay. Thank
Mhm.
you.
Yeah, and it also takes out sort of all any variability from instructor to instructor. So that keeps us honest. That keeps all the instructors on top of things as well. Great, good question. All right, so these are our courses. There's a lot, right? There's a lot of pieces there, and it looks like a lot when you look at it like this, and you go, "Oh my gosh, how am I going to do all this?" Um, but let's look at that a different way. Let's kind of sort that information a different way. Like, what are we going to do in class versus what's going to happen out of class? And you can see a lot of what we're doing is going to happen in class. All the exams will happen in class. Obviously, all of our labs will happen in class, right? The only things that are going to happen outside of class for lab are your pre-labs and your lab quizzes. Um, your good habits points, some of them are going to happen in class, like attendance. And other good habit development activities that we do, our discussion groups will happen in class. Out of class is when you're going to be doing those, you would probably call them the homework parts of things, right? So the developmental practices, those are going to happen on your time, the preparations, some of our good habits, right? If you want to go to the Science Learning Center, your reflections for the week, any outside events you go to, those are going to happen there. The portfolios, again, kind of the big piece of things out there that will happen outside of class. And then, right, even though these things that just dropped in are not a part of our class per se, like you're not graded for those, but any extra practice problems you want to do, any extra tutoring you want to do, or study groups that you're going to work with, or attending office hours, those are all things, again, those would be things to budget for outside of class time. That might vary, again, depending on the topic, right, and on your particular needs or backgrounds. Haley, did you have another question? Okay. I thought sometimes the hands get left over. They get left in the up position. That's okay. All right. Any questions on this sort of how things are going to be distributed? Okay. So what you just saw is something that we'll see quite often in this class. We had the same information, but presented a couple of different ways. Um, that, by the way, is my job. That's to help you see this information and to kind of help you sort it out. And maybe one way of presenting it is helpful, and maybe it's not, right? We want to present it a different way. So if you're not getting it, right, or you feel like it's still a little bit fuzzy that way, by all means, right, throw your hand up, right, in class, and ask. And my job is to try and find another way to kind of help you see it, right? So I've got in my brain lots of different ways of presenting things. I can't do them all in every class, even with our extra 2 hours. So we'll try a couple of different ways, but if it's not working that way, let's find out a way that does work for you, right? So absolutely, interrupt me, please. Make sure I come up for air every now and again. All right. So here's what our class is going to look like, right? Just to kind of, again, kind of sort out, oh my gosh, what's going on with all these pieces? Let's sort it out a different way. What's going to happen before class? What's going to happen during class? And what's going to happen after class, right? Now, to be fair, if I drew this correctly, the during class time, even though we are together, oh my gosh, it's like 10 hours a week, I think, right? 9 or 10 hours a week we're together. That during class time should probably be super tiny, right? Because all the things you do before class and after class, that's probably where the most of your time is going to be spent. So I don't know for how many of you is this kind of your first, I don't know, I'll say STEM class, science class at college. Anybody? We've all been around the block a few times. We've all had lots of science classes. All right. Yeah. So it's different, right? So the things that might have worked for you in another class might not work for you in this class. So the rule of thumb is, and again, it's variable, depends on the course and your background and the topic within the course, 3 hours outside of class for every 1 hour in class, right? So that's already a time commitment because our class is already a lot of hours together. So when you think about all the time you're going to need to spend reading and prepping, right? Pre-labs, lab quizzes, and all the things we're going to do after class, practicing those concepts. That's where that time is going to go. That's where we're going to spend most of our time. So before class, we're going to read, right? That's our prep guide. It's designed to help you do that reading in a more effective way, kind of guiding you through what do we need to get out of that. Take a look at what's coming up. Take a look at the end of the chapter where the problems are, right? You don't have to do them, right? Obviously, if you could do them before class, I would be useless. But take a look at them, see what you're going to be asked to do with that knowledge, right? Think about what your questions might be so that when you get to class and during class, you know what to ask about, right? Your brain is ready to solve certain types of problems or think about certain definitions, right? So you can add some notes to those slides. But ask questions there is in giant letters because, oh my gosh, please, please, please. That's what keeps class interesting for you and for me, is asking questions, right? Not just listening to me go on and on because I could do this for hours at this point. And then after class, you're going to work on those assigned problems, which could be developmental practice, portfolios, extra practice, whatever you need. Get help and give help, right? So it's both. When you're doing asking questions or answering them, you're learning, right? That's part of it. And you'll probably come up with more questions. So make sure you write those down. I don't know if you've noticed, but these are the things that were in our syllabus. We're preparing, we're participating, right? So that's kind of the active part of our class. And then we're practicing, right? The fourth P is the performance. Those are the tests and quizzes. So we'll get to those. All right. So hopefully that kind of gives you that little bit of a picture of what we're up to. All right. So what is going on with our frog here? You are going to be so excited to see this frog all semester long. This frog is the reminder to me and to you that it is time probably to take a little break. So what's going to happen when this little frog appears is I'm usually going to give you a little chance to breathe, catch your breath, sit back, relax, right? I might give you a little prompt to kind of think about there, right? So we've been going for about 40, 45 minutes now. Think about what you're thinking about of our class. There's a lot in it, right? So think about your emotions so far, right? That's a component of you, right? Right? Think about what your emotions are. What are you looking forward to coming next in our class? Jot down any thoughts, feelings, plans, right? These are going to be your little reminders to yourselves in these little moments where we catch our breath of what comes next, right? So if you're thinking about something or you had a question that you might, or something you want to go back to, here's your place in the slides to note that down. Take a breath, doodle, whatever you need to do. So let's take a little break here. Let's take a 5-minute break here. So we'll come back at, let's see, what is my official time here? So let's come back at 12:53. Or 12:54 now, 12:54. And we'll get started and we'll shift gears from course information into, well, if I say math, will you all promise you'll come back? All right, we'll talk about some of the math components of this and we'll work on getting those skills up and running So we'll be ready to hit Wednesday at full speed. All right, so let's take 5 minutes here. I am going to just turn off my camera and my mic for a little bit. But if anyone has questions for me or wants to use the direct messages in the chat box, we can do that as well. All right, so we will shift gears now. Again, if you think of any questions having to do with sort of course procedures or policies, absolutely email me, right? We can hang around after class and chat about them. Also, on Friday, again, if we're not super far behind, one of our activities will be to kind of review and recap all that in a shorter way again with a different activity. Okay. All right. So let's look at our brain for a minute before we get to the math. Right? Let's look at our brain, right? And look at why do we even do these things? Why do we have things that we ask you to memorize? Why do we have to work on this math part of things so hard? And that's just because of the way our brains work and what we're trying to do here. So we're trying to solve problems, right? We're not just trying to know stuff, right? So we're not just a bunch of facts, right? That's not helpful, right? That is not what we're about. We want to be able to solve problems. We want to take that knowledge, that definition, that concept, that relationship, and do something with it, right? And apply it to a situation. And in order to do that, in order to solve problems, right, there's just a certain amount of stuff you have to know, right? If you don't know anything, you can't solve that problem, right? I could give you a problem right now in chemistry, and because you don't have a lot of those definitions or concepts understood or memorized, you're not going to be able to solve that problem, right? So we want to be able to work on being so well versed in some of those basics, like math, because our science of chemistry is quantitative. That's what makes it different, right? It's very predictable in that sense. A certain amount of this material and a certain amount of that material makes a predictable amount of products, right? It doesn't depend on the phase of the moon or what color shoes you're wearing. It's very predictable, right? So understanding those relationships and understanding them very well is going to free up space in your brain to do that problem solving. So if we can get information into our long-term memory, that's going to help our problem solving, right? If you think of your brain kind of like a computer, right? You've got that working memory, right? And if your brain is working real hard just to try to remember that C is the symbol for carbon, right? That's taking up space that you could be using to solve the problem, right? So we want that information, C means carbon, to be automatic, right? So that's what we're working on developing when we say, these are the things you need to memorize. So there are some things to memorize right away in chapter 1, and those are the metric prefixes. You're going to get a list, again, when I give you that purple folder, when we can finally be together. When you get that list, there's going to be a list of everything to memorize for the whole semester by week, right? There's some things for the first week. There's a lot of stuff for chapter 3, round about week 3 and 4. And then a lot of stuff around chapter 5, and then not so much for the rest of the semester. But you'll have that list. That takes longer than you think. That memorizing takes longer than you think. Some of those things you may be familiar with, right? Some of them you're not familiar with. This is part of why we have this course with O31, right? It's to kind of fill in those gaps. So take a look at that information. In fact, I'm going to put a little note to myself. I'm going to send you that list today of things to memorize so that you don't even have to wait till we can get together again. But that's what we want to do, is work on that automaticness so that you can take that knowledge and apply it to something else. All right. So how do we do that? How do we get things, right, that we've just learned about, that we've just read about, just experienced in class? How are we going to get that into long-term memory? What are some strategies? What are some things you need to do to make that work? Okay. So you can put it in the chat box, you can shout it out, you can raise your hand. Okay. Practice, constant practice. Right. So not just once and done, right? Right. Starting it earlier, right? Giving yourself enough time to do that. Repeating it, active recall, right? But everybody know what active recall is? It's where you actually just, right, cover it up. You're not looking at your notes and then reciting it, right? That's not recalling anything, but it's actually covering your notes, putting them away and trying to recall that information. That's a great way to do things. Yeah, repetition, right? It's not going to happen in once. Spaced repetition. Oh my gosh, absolutely. Teaching it to someone else, perfect. Yeah, right. Looking back. Right? All right. So this is usually something that I demonstrate to you while I'm learning your names. So normally we have a little activity, and by the end of the first class, I usually can put a name on everybody's face. So it's a little, I can't do that today because I don't have everybody's face. But hopefully I'll be able to show you how I do that, right? Just kind of on, fingers crossed, on Wednesday when we do that. All right. So learning incrementally, that's right. Starting early enough, right? Not trying to do it all at once, right? It's not going to happen that way, right? Learn a little bit, right? And then add more to it, right? And then add more to that, right? Space it out. Those are all things you guys have already said. Parallel processing. We didn't have that one, but that's using all of your senses, right? One way that you can do that, super easy, go to the Science Learning Center, grab a whiteboard and try and write them down, right? Now you're using your body, right? You're being more physical, you're standing up. The whiteboard is magical that way. I don't know if it's just more oxygen to your brain or something. I don't know. But using a whiteboard, right? Right. So if you've got one at home, fantastic. If not, hang out in the Science Learning Center. We've got tons of boards you can doodle on, right? Using different modes. So listening, maybe watching a video as opposed to just reading something visual, right? Writing things out, right? Making a model. Those are all, that's what parallel processing is. Okay. Overlearning. So that's part of that repetition, right? So don't just learn it and go, I've kind of got it. I've got 80% of it down. Overlearn it. Learn it so well. You can right, see it in your sleep. Just making an effort, right? If you don't do anything, well, absolutely nothing's going to happen, right? So do something, even if it's just a little bit. Even if you feel like, oh my gosh, I've only got 10 minutes, why bother? That's 10 more minutes is better than zero, right? By a lot. Focus on the core skills. What are the important strategies there, right? So again, right? Time is a limited quantity. So if you're feeling pressed for time, think about what those most important essential skills are. What is it that we're using every time? Right? Test yourself. That's that active recall. That's testing yourself. And the one everyone forgot. Have we all forgotten the importance of sleeping? Well, that was a lot of your goals on your prep guides this week, was to make sure you got enough sleep. And that is a fantastic goal, because the way your brain works, right, is things get moved into that long-term memory during your sleep cycles. Right? If you're not getting enough sleep, you're not going to be able to learn. Right? We've all done that. We've all stayed up way too late, too many nights in a row. And you know that at some point it becomes not effective. Right? You're actually losing information as you're losing that sleep. So put sleep on your schedule, right? Make sure that it's there. Make sure that you're planning ahead to get as much sleep as you need. All right. Okay. All right. So here's what we need to do. Here's the math part of this. So if you can recall those math facts quickly from memory, right? Or the or the relationships and the connections and things that are chemistry, that there's gonna be a lot of those that are those proportions, right? So your working memory, right, needs that speed. If it's spending all day spinning its wheels just trying to remember what a millimeter is relative to a meter, we're going to lose track of, well, what was the whole point of the question? What problem was I solving? So here are the 4 things in terms of old math skills, right? So that's why this is in chapter 0. This stuff is not in our textbook. It's not a part of first semester chemistry courses. These are things that we're assuming you've already got down. Now, if you already have them down, if you feel like, oh my gosh, I know all this, I'm bored out of my skull, good for you. Absolutely awesome. But I will challenge you to try and find something new in there, right? Something you might have forgotten about, right? All of us have rusty algebra. We might have been awesome at it back in 8th grade, right? But that is a skill that might have left us, right? It's in there. We just have to access it. All right. And then we'll definitely work on our calculator use. If you're not using your calculator all the time, it's not really that you forget how to use it. It's that you become inefficient and you may be inaccurate. You may be asking it to do things in a way that's not compatible with its programming. All right. So these are our 4 topics for the rest of chapter 0. All right. So grab your calculators. All right. Here is your problem to do. 5 plus 2 divided by 3 minus 1. And I know you're all thinking, oh my gosh, chemistry is going to be so easy if that's all it is. All right, give me a thumbs up when you've got that all calculated out. All right. Okay, let's see how we did, right? With our order of operations. All right. Here's what order of operations is. These are the rules, right? Math is full of rules, and these are the orders that things happen in, right? So things that are in parentheses are going to happen first, right? Things that have exponents will happen second. Then we do multiplication and division, right? Those are 2 sides of the same coin. And then addition and subtraction would happen last. All right, and I am almost willing to bet that nobody followed these rules when they had that problem up there earlier. Okay? I'll bet we didn't do them in that order. All right. So our calculator that you're holding in your hot little hands that you trust, right, with your grades, because those are the answers you're going to write down. Whatever my calculator says, I'm going to write down. Your calculator cannot see the math that you want it to do. You have to tell your calculator exactly what you want it to do. Right? What you're typing in might not be what you think you're telling it to do. Right? So for example, that at the bottom is what was intended by this sentence up at the top. Right? It's not clear. It's not clear what was going on there. Right? If you just wrote that problem out, 5 plus 2 divided by 3 minus 1, and followed the order of operations, right? You would do the multiplication and division first, right? And then the addition and subtraction, right? So you would end up with 5 plus 2/3, 0.667 minus 1. And you would get 4.667. Anybody get that? Anybody? Anybody follow the rules? All right. All right. So one of you did it this way. One, maybe more than one. I didn't check. Couple of you did it that way. A couple of you noticed the heading that said order of operations. You're like, oh, I'm going to pay attention. I'm going to do that. All right. And you did, and that was correct if you were following order of operations, right? If you just did it as a sentence, right? Just entered it in your calculator, 5 plus 2 divided by 3 minus 1, right? You would effectively be doing, right, the 5 plus 2 first, right? Gives you a 7, right? You divide that by 3, you get 2.331, then you subtract 1. Is this what most people got? 1.333? Nobody got this one? Right. So this is what you'll get if you just enter it in as a spoken word. 5 plus 2 divided by 3 minus 1. Right? This third way is what happens if you put in those parentheses, right? Which was what was intended by this problem, right? 5 plus 2, right? Do that first, divided by 3 minus 1, right? If I speak it, I can almost put those parentheses in there. If I say 5 plus 2 divided by 3 minus 1, I don't even have to talk with my hands. But if I talk with my hands, I can say 5 plus 2 divided by 3 minus 1. Please note that my calculator, as awesome as it is, cannot see me. It can't see what I'm intending, right? So if we're intending that bottom statement there, then we're going to have to enter in those parentheses, right? So that our calculator knows to follow those rules. Okay. We really have to be careful that our calculators don't have eyes, right? They're just going to do the math in the order that you tell it to do the math. So unless you put some parentheses in where needed, it's just gonna carry on and do things probably like the second line in this slide, right? So your calculator doesn't necessarily follow order of operations. You're gonna have to tell it what things you want done first and what things you want done later. Okay? Especially when you've got mixed things with some multiplying and some adding. God help us if there's something to a power in there, right? We're going to have to be, again, sort of really careful that what we're inputting in our calculator represents the math that we're trying to have it do. Right? And that's probably not something we've thought about for a while. Right? That's just not part of our everyday experience. Right? But you can see we get 3 different answers depending on where we put, right, sort of how we group that math and in what order we do it in. Right? So we need to be very mindful of what math is it we want to have happen, right? And how do we tell our calculators to do that math and not some different math? All right. So that was order of operations. Again, there's going to be a little section on your first developmental practice that's going to let you kind of practice with that a little bit more, do a little more reading, a little more practice in your portfolio as well. Okay. On with our world tour of math, on to algebra. Okay, I'm not going to teach you algebra in the next 5 minutes, right? This is more of a refresher to kind of go back and ping that part of our brain where the algebra is hiding out there. Okay, so can we look at that first sentence, the math sentence? 3 plus 6 equals 9. Can we agree that that is true? Is that true? 3 plus 6 equals 9. That you've got your calculator, you can check just in case. Does that look good? Are we okay with that? Huh? Okay. So algebra is really the ultimate fairness, right? In order to keep those 2 sides equal, right, we can do anything we want to that math sentence as long as we do it to both sides, right? Then it will still be equal. If we do the same thing to both sides, it will still be equal. So we can do anything we want to this, right? But we have to do the same thing to both sides. And it'll still be equal no matter what the results are. So let's look at our first, our choice A there and decide, is it true or false, right? So thumbs up or thumbs down, I guess. Yes or no for true or false. See, this is where our cards would come in handy if we were in our classroom. We would have true and false. Okay, so statement A, is that true or false? You could use the chat box too, right? That's also an option there. Okay. All right. Good. All right. Anybody want to tell me why it's true?
Because technically it's equal in both sides.
It is equal on both sides, right? We did the same thing to both sides, right? We subtracted 3 from both sides, right? And if we went ahead and did the math, it would be 6 on each side, so it would still be equal. All right. How about statement B? Is that true or false? All right. Lots of folks think it's true. All right, anybody want to tell me why it's true? Right, Zara, go ahead.
Because we multiplied 9 on both sides.
So we didn't multiply 9 on both sides. We multiplied two on both
Oh,
sides.
2 on both sides,
Yeah,
sorry.
the 9 was already there, yeah. But yeah, we multiplied this in this case, right, by the same thing on both sides. So, right, if it was equal before, it's still going to be equal at the end of that, right? That's how algebra works. Okay. Usually we do that for a purpose. How about the part C? Is that true or false? That one's a little trickier, isn't it? All right. All right. We've got a lot of no votes on this one. All right. Why is that one not? I mean, it looks almost true, doesn't it? What's going on with this one? Okay. So it looks like there's a 6 on both sides, but on one side we added it, and on the other side we subtracted it. So we had the same number, but we did different things to both sides. We made one side bigger and the other side smaller. So no, of course they're not going to still be equal to each other. So that one's false. How about part D? Now we're going to get weird. We're going to get some of our algebra symbols in there with our letters. So is D true or false? All right, so that one is also true. What did we do to both sides that was the same? Okay, go ahead, Zara.
We multiplied it by a y.
By y, yeah. So again, this time we didn't know what y means, right? Before it was a 2 that we multiplied by. This time it's just a variable, right? Could be a unit, could be another number, we don't know. Yep, so that one's true. All righty. And how about E? Is that true or false? Okay. Good. Good. So that last one's also true, right? Why is it true? All right. Thank you, Haley. Yeah, they're both raised to the same power, right? So again, it doesn't matter what we do to both sides. We could add, we could subtract, we can multiply, we can divide, we can raise it to powers, right? We can do anything we want to both sides as long as it's the same. And algebra says it's still a true statement, right? And that's what algebra is all about. It's all about being true and it's about being fair, which is, I think, a very noble goal, right? So despite what you might think about algebra, right? It's really got that as its core, right? It's all about being fair and it's all about keeping things balanced and equal. All right, so let's take that knowledge, right? Now, what makes algebra challenging is, well, how do I decide? I need to decide to do something to keep things, right, equal on both sides. Because usually we're trying to solve for what that variable is, what that letter is in our equation, that thing that we don't know. Right? That is what the whole point of algebra was. Let's find out what we don't know. Right? And we're going to find it out by doing the things that we just saw on the previous slide, right? Doing the same thing to both sides, right? That keeps it equal. But our goal is to try and get that variable all by himself, right? So we're going to start with, and really, I think of this like an onion, right? We're going to start with whatever's furthest away from that variable, right? And sort of peel it away, sort of do the opposite of it to try and make it go away so that that letter, in this case, Y, will be all by himself. All right. So again, you're going to see slides like this throughout our semester, right? There's going to be a question at the top. It's always going to be in this color. So you'll always kind of have that that visual clue that, oh my gosh, I need to do something now. I need to find my calculator, need to get my pencil ready. And it'll say in class practice up there on at the top, right? So, and it'll usually be a slide with a lot of blank space on it, right? It's for you to participate, right? As we go through our class, to participate and add to, right? And work things out, right? Because this is your chance while we're all together, right? Is to try things out, right? And if it works, great. You're gonna get that little dopamine hit when you get that question right. Or if you get stuck, right, you've got a whole room full of friends and an instructor who's there to kind of help you and point you in the right direction. All right. So let's do that first one. I'll say more or less together. Okay. So we're trying to get that y all by itself. So we want to look at sort of what's happening to that y. He's got a minus sign in front of him, but he also has 273 added to himself, right? So to solve this, we're not going to start with that minus sign. We're going to start with the thing that's furthest away from the y. I'm going to start with that 273. All right, so what can we do to make it go away from the side on the y? Right? Okay. So we're adding 273 to our minus y. So we're going to do the opposite of adding 273. We're going to do minus 273, but we have to do it, right, to both sides to be fair, right? If we don't do it to both sides, then it's not going to be equal anymore, right? That's what algebra is doing, right? So we're trying to, on purpose, do some sort of math maneuvers that are going to end up isolating that variable all by himself. Okay. So the first thing we'll do is we'll subtract 273 from each side, right? And let's see what the result of that is, right? So 27 minus 273 is negative 246. And when we subtract 273 from the right side, right, that becomes a 0. And we have just left with the minus y. Right? So it's not y, it's the minus sign is still there. That didn't magically disappear when you subtracted 273 from both sides. That minus sign is still there. Okay, so now we need to get rid of that minus sign. So if we multiply both sides by -1, or basically, right, change the signs of both sides, right? If it was positive, we'll make it negative. If it was negative, we'll make it positive. That's what multiplying by -1 does. It doesn't change the numbers, it just changes the sign of it. Right? We have that y is equal to 246. Okay. Now, some of you may have been able to solve that in a slightly different way, might have done your steps in a different order. Again, as long as you did valid steps, you should end up in the same place. Right? How did we do on that one? Were we able to see our way through there? Okay. Oh my gosh, do we hear the rust in the gears in our brains shaking loose there? All right. This other one I chose as an example, part B, because it's always a challenge when our variable is in the bottom, right? That's always a little more challenging, right? So let's do the same strategy we did before. We're going to try and get y all by himself, right? By sort of peeling back the layers of all the math that's happening around the y. We'll start furthest away, right? So there is an 85 there on top of the y. So that the opposite of an 85 on the top is an 85 in the bottom, right? So that's dividing by 85. So we're going to do that to both sides, right? So again, we can't do it to just one side. We can do it to both sides. So if we divide both sides by 85, right? We have 0.4 divided by 85. That's just a number, 0.0047, right? What's left on the other side is not y, right? Because the y is still in the bottom. Again, it didn't magically pop up into the numerator, right? Into the top part. It's still in the denominator, in the bottom part there. So we have 0.0047 equals 1 divided by y. You're like, oh my gosh, how am I going to get rid of this, right? So you can do the inverse of both sides, right? So flip those relationships over, right? Do the same thing on both sides, right? You could cross multiply, right? We know in algebra that the numerator of one side times the denominator of the other equals the numerator of the other side times the denominator of the first side. Right? So there's a lot of ways we can solve this problem algebraically. But since we're at this position, I'm just going to flip both of them over. Both sides, right? I can't flip one side over and not the other, right? Then they won't be equal anymore. Okay? But I could invert or take the reciprocal of, if we want to use our math words. So 1 divided by 0.0047 is, right, y divided by 1, and that is 212.5. Right. So that was a little trip down memory lane with our algebra there, right? So the two I chose have both of them have sort of common things that we'll see in chemistry, and that usually throw students for a loop. One is when there's a minus sign in front of the variable, so that's part A. And one is when the variable we're trying to solve for is in the denominator. So that was our example B. So these are both sort of examples of reasonably challenging algebra problems. Okay. Again, if they were not challenging for you, then yay, good for you. The algebra part of your brain is very much awake and functioning. For the rest of us mortals, right, we get to shake the dust off of our algebra skills there, and work on getting them moving forward. Okay. So let's just check our brains here. So I am going to do my very best to not say a word for 2 minutes and let you solve this. As you can probably already tell, that will be a challenge for me. Right. So try and solve this. Since I can't see you, if you put a little thumbs up when you've got it done, so I can kind of tell when we're making progress here. How are we doing out there? Got it? So again, we want to start as far away from the y as possible. So we're going to start with that. We're going to start with that +6 and kind of get rid of that. Get that onto the other side. So we're going to do the opposite of +6ing, which is -6ing. So we'll do that first. All right, and we're left with y minus 2, and then that whole thing is squared. Right? So we can't do anything with that y that's inside that parentheses until we get rid of the things on the outside, right? So we get rid of that squared. So we have to do the opposite of squaring. Right? And here's where we might have forgotten what the opposite of squaring is. The opposite of squaring, yep, Thank you, is the square root. Absolutely. So we're going to take the square root of both sides. That'll be our next step there. Right. All right. So now we're left with just the y minus 2. And that's the square root of 14. Right. If you put it in your calculator, you'll get some number for it. 3 point something. And now again, to get that y by itself, we're gonna do the adding 2, right? We do the opposite of minus 2, which is adding 2, but we have to do it to both sides. Right? So square root of 14 plus 2, 5.7. Okay. So yeah, so you don't have to do it all at once. In fact, it's probably best if you just do one thing at a time, especially while we're kind of working our way through this. Again, your developmental practice 1 has some work with algebra. Your portfolio has some work with algebra there. So you can both with numbers and with just symbols. So we can work on that. That shake up any questions that we've got. So we've got our frog here, but we're only 15 minutes from the end. So I'm going to ask you just to take 30 seconds here and just maybe close your eyes and take some deep breaths. Think about the math part, right? Think about how you're feeling about the math part. Think about where your math skills have been. What do you need to work on? When we can get back on campus. The Science Learning Center has some extra practice just on algebra skills. So that you can go and you can get help with those with some very kind and very patient human beings there. Just ask them for the extra practice for algebra and they will get it for you and help you work through that. Okay. So think about what you need to review, sort of where your strengths and weaknesses are, right? That's what the little frog's bubble is for you to write that down and so you don't forget about it. Because you'll think you remember, but you won't, because in 2 minutes after we leave here, you'll have forgotten, right, what it was you were going to work on. All right. So in our last 15 minutes, I'm hoping that we can work through scientific notation, right? We're probably just going to save our calculator practice for Wednesday, which is fine, because that's always better if we can do that in person. Really hoping we're in person now. All right. So scientific notation, you've probably seen this, right? It's a way we can write super big numbers or really tiny numbers. And we're going to see both of them in chemistry, right? We're going to see very small things. We're going to see very big things, large numbers of things, right? So we're going to write these very big numbers and very small numbers as a sort of reasonable number, something between 1 and 10, times 10 raised to a power, right? So that times 10 raised to a power is really just telling us where do we put that decimal point. Do we put it way over on the left, right? That means it's going to be a small number. Do we put it way over on the right? That means it's going to be a really big number, okay? So our math words for that are exponent, right? That's our power of 10, right? So 10 to the third, the exponent is 3. That's 10 to the third power. All right. So here's what's going on. When we have a number that we write in scientific notation, our math words for those different parts are the coefficient. That's our number between 1 and 10. That's what we write first. And then we have an exponential term. That's the times 10 to a power. Okay. That's what your scientific calculator is going to have a special button for. It's going to have a special button for times 10 raised to a power. So you don't have to type all that in all the time. When we're converting from sort of our regular form, or we'll call that decimal form, right? All the numbers written out with all the 0.000s in it. And when we convert that into scientific notation, we're going to focus on the significant digits. That's again another topic for Wednesday, so we'll see that acted out. But so don't fret about that yet, but realize scientific notation is going to be a nice way to help us show proper number of significant digits from our measurements and calculations in a nice, easy, convenient way. So again, we've seen numbers like this, right? We just want to practice a little bit, kind of going back and forth, so we get a feel for what it means to be a very big number or a very small number. Okay, so here are a few of the powers of 10. Obviously, we can raise 10 to any power. So it doesn't have to be just these values. We will see powers of 10 bigger than this and smaller. But numbers that are bigger than 1 have a positive power, right, for their exponent, right? So anything to the 0 power, that's right in the middle of our chart, that means something times itself 0 times. So that's just a 1. So anything to the 0 power is a 1. Right? If we raise it to positive power, so that's the top part of the chart, you can see what's happening. Those are all numbers that are bigger than 1. Those are all things that are going to make, if we multiply a coefficient by 10 to those positive powers, that's going to make that number bigger, right? We're multiplying by a bigger number, right? The powers of 10 that are at the bottom, the negative powers of 10, those are all smaller than 1, right? So when we're multiplying our coefficient by one of these negative powers of 10, we're making that number smaller. We're representing a smaller number, right? But without writing all the 0.000s. So numbers that are smaller than 1 have a negative power of 10, right? That's sort of the concept to keep in our head. Like that's sort of the big idea of powers of 10, right? So if we can keep that idea in our head, that's going to help us solve these problems, right? We're going to be able to apply that information to our new situation of converting things from decimal form to scientific notation and back and forth. All right, so we're going to use our brains. We're not going to memorize, do I move things to the right or left? That's a disaster, right? Especially as a teacher, because my right and my left are different from yours, right? They're exactly backwards. So it's very challenging. So I will challenge you to not think about right, left. Let's think about bigger and smaller. Let's think about what it means to be bigger or smaller. So let's work on this table, right? So we'll do the first one together. So we're going to change them either from decimal form into scientific notation or from scientific notation into decimal form. Right? So let's take a look at that first one. That's 5,330. Right. So what we're going to do is we want to represent it as a number between 1 and 10, right? Times 10 to some power, right? So where is the decimal point in this number? I'm not seeing one. Yeah, so it is after the 0. It's sort of implied that it's there. We usually don't write that decimal point down unless there's something that comes after it, right? So this one has an implied decimal there. So let's put our finger, right? Our finger right on that, right after that 0, and move that decimal point over until you get a number between 1 and 10. Okay? So how many places over are you going to move it? Okay, good. Right, so you've moved it 3 places. So now you've moved that decimal point between the 5 and the 3, right? That gives you 5.33. That is something that is between 1 and 10. All right, so now we need to write that in scientific notation. So we'll have 5.33 times 10, right? Now, is it positive 3 or negative 3?
Positive.
Yeah, it's positive 3, right? Because this is clearly a big number, right? Right? We didn't have to memorize, oh, I moved it to the left and that means positive. No, right? Let's just think about it. If this is a big number, right? It's bigger than 1, 5,330, then we're going to have a positive power of 10, right? So if I move it 3 places, that means 10 to the positive 3 in this case. All right, so I'm going to let you try, let's just try the next 2 real quick. Try and write those out in scientific notation. And we'll check those. All right. if we were in person, we would be writing this on the board and it would be going very quickly because we could do all 5 of them at the same time. We could have 5 different people up there answering these questions. But we'll have to take it a little slower today. All right, so what did we got for the second one? Anybody? Did you get a positive power of 10 or a negative power of 10? All right. So yeah, we should have all the digits in there, right? So we don't lose any of the digits just because we've changed into scientific notation. Yeah, so 1.3658147, right? Times 10 to some positive power. So how many positions did we move it? 7 positions over. So times 10 to the positive 7. All right. And the next one, how do we do for that one? Again, we have a really big number. So you should have a positive power of 10 at the end of the day. 7.5 times 10 to the positive 4. Right. So for those of you who are in the chat box typing, you realize how annoying it is to try and type math. Right. This is one of those. This is really the main reason. Right. If you don't format it correctly, it's not clear. This is why I have you write out your practice portfolios and try and encourage you to do as much as you can, right, with your hand and not with a keyboard. Because it makes a difference where we put that information, right? If you don't have that 4 in the right position, it's going to look like 7.5 times 104. That's not the same thing as 7.5 times 10 to the 4th. Wildly different things. All right, so let's try the 4th one there. We're going to go in the other direction. All right, we've got 1.00 times 10 to the 5th. Okay, that's a positive power. That means we're going to be making a big number. So we're going to move that decimal point 5 positions in the direction that makes it bigger, which is going to be to the right. So when we do that, we get 1, 0, 0, 0, 0, 0. Right? We got to fill in all those blanks all the way up to our imaginary decimal point. So 100,000 there. All right. So try the next 2. Oh my gosh, we'll try to not get lost in all the zeros in the next one. Are we going to have a big number or a small number for the 5th one? Oh my goodness. Lots and lots of zeros on that one, right? So you're going to move that decimal point 11 positions, but in the big direction, right? Over to the, over towards the right there. So you're going to get 466 and then 9 zeros. That's a really big one. Yeah. All right. Awesome. How about the 6th one there, the bottom one? That one's a little more reasonable. We didn't have to move the decimal place that far, only 2 positions, but again, in the direction of bigger, right? Awesome. Oh, terrific. All right, so there are all the results, okay, which lets me remind you that after we finish a chapter, right, the slides that had blanks on them where you were filling things in or answering problems, I post the full set of slides with all the answers in there, right? So if you miss something, right, you don't have to worry about jotting everything down when we're solving problems. Realize that you're going to have those completely filled in slides available to you after we finish that chapter, right? So before we do it, they're blank so that you can work on it during class without peeking at the answers, right? We want you to engage your brain fully during class. So again, if you don't get these all jotted down, that's fine. The solutions will be there after we finish chapter 0. All right, so let's try it real quick in our last 4 minutes here. Let's see what we can do with these. All right, so I'm going to give you 2 minutes to do all these, and we'll look at the answers after 2 minutes. These ones are all small numbers, right? You can see they're all tiny, tiny numbers. They have negative powers of 10 or lots of 0.000s. All right, so feel free to drop the answer to any one of them into the chat box when the spirit moves you. You guys are doing a good job of not losing all of the digits just because we've switched into scientific notation or back again. All right, so we got that first one done. If anybody's got the second or third or fourth one done. Okay, good. 2.3 times 10 to the minus 3. It's our third one.
For the third one, wouldn't we have to also add the last 2 zeros?
We would add the last 2 zeros again, because they are significant digits. Again, we haven't really talked about that yet, but yes, for number 3, it would be more correct. 2.300 times 10 to the minus 3.
All right, thank you.
Good. Awesome. All right, so 3.3 times 10 to the minus 7. That's our second one there. All right, how about the ones at the bottom there? Let's go in the other direction. Those are more annoying, right? Because you got to type in all those zeros. Now you know why scientific notation is awesome, right? Yeah, so there should be a decimal point and then 4 zeros and then the 7 for the first one. Yep, so 0.00007. Right, yeah. The next one's nice, right? It's only 1 decimal point we have to move over, and we're making it in the smaller direction. So 0.26. And our last one. Great, awesome. Thank you, Betsy. Yeah, 0.00535. Now, your calculator may have a button that does this for you automatically. Okay? That doesn't mean you shouldn't know how to do it, right? Knowing sort of what to expect is going to help us when we start practicing with our calculator. Like, does my answer make sense? Should I have gotten a really big number? So by being able to do that sort of a little bit of mental math will help you there. All right, let me give you a few knowledge checks. That's how we'll end our day here with only two little multiple choice questions. So again, we're going to use the chat box, or you can just shout things out. Chat box is probably more polite at this point. So which of the following is 0.0015 inches, 0.0015 in scientific notation? Good. All right, awesome. It is B, right? It's definitely a small number, so it's not A. And then it's a matter of how many decimal places do we move that decimal point. It's 3 places. All righty. Okay, one more. Which of these is 5.005 times 10 to the minus 4 in its decimal form? Right. Okay. Well, I think we've got the hang of this. That's awesome. Yeah. Perfect. Right. Since we have another small number, we're going to end up with something less than 1. Right. So that eliminates the first 2 choices there. And then we've just got to get things written out right. Awesome. Perfect. All right. So when we come back on Wednesday, hopefully in person, we're going to pick up where we left off with our calculator practice there. Thank you all for coming. I appreciate that. You guys are awesome. I will work on uploading this. So again, if you have a friend that wasn't here, they'll be able to catch this. I am going to